Okay, so now we're going to simplify, but the radicands are going to have higher exponents. So let's say you have the square root of x to the 6th power, okay? And so what we're going to do is we're going to think of that as the square root of x cubed squared. Now, that's a rule that when you have a power to a power, you multiply those powers. So it says if you have a to the m and you're raising that to the nth power, that equals a to the m times n. Okay? So 2 times 3 is 6, so we can write it that way. Now what we're trying to do is we're trying to get whatever the index here, and that's a square root. So the index is 2. We don't write the 2 when it's a square root, but we want it to match to the exponent over here. Okay. So then we can say that that equals, now it's an even root, so we're going to use absolute value of x cubed, okay? And that's the answer, and we're done. Okay. Now we're going to think about, what if I had the square root of x to the 12th? So you're thinking, okay, well, I'm going to do what she did on the last problem, square root of x to the 6th squared, okay? And that's fine and good. And then you say, oh, it's the absolute value of x to the 6th. But here's the thing. X to the 6th, when we have an even exponent, it's going to be positive no matter what, so we don't need the absolute values. So we would just write x to the 6th, and we wouldn't write the absolute values. Okay? All right. So you can think about that for a minute. You can look in the book, but I don't know if their explanation is going to be any better. But all right, let's say you had the cubed root now of x to the 12th. So you say, okay, well, that's going to be the cubed root of x to the 4th to the 3rd, right? Okay, so you're trying to get that index and exponent to match up. And then you're thinking, oh, it's going to be the absolute value of x to the 4th, but it's not. It's going to be x to the 4th because it's an odd root, so we don't do absolute values on the odd ones. Okay, so it's just x to the 4th. Okay, so that's going to come up a little bit later on. All right, so now we'll try some. So we have y to the 18th, and it's the square root, so we're going to think square root y to the 9th squared. Okay, so that's going to be the absolute value of y to the 9th. Okay, and it's a square root, so I need the absolute value. I'm going to keep the absolute value because y to the 9th, we don't know if that's positive or if it's negative. It's to an odd exponent. So if y is a negative number, it's going to be, y to the 9th is going to be negative. If it's, yeah, okay. So keep the absolute value there. That's the answer. It kind of becomes, when do I keep the absolute value and when don't I? All right, so part B. It's the square root of z to the 6th squared. So that's going to be, and this is how I'm doing it in 2 steps. The absolute value of z to the 6th, but then I decide I don't need the absolute value because z to the 6th is positive no matter what, because this is even. Okay? All right. So you might have to let it marinate for a little bit. Think about it. Okay. So we'll try some more. A. So you've got the 4th root now of u cubed to the 4th power. Because 3 times 4 is 12, so that's not a problem. And now it's a 4th root, so maybe I need the absolute value. So let's take the absolute value of u cubed. Okay, but u cubed, I don't know if it's positive or negative because I don't know what u is. So I keep the absolute value. Okay. Part B. I think of it as the cubed root of v to the 5th cubed. So hopefully that's getting a little bit easier for you. And then I think, oh, I don't need the absolute value because it's a cubed root. Okay, so cubed root don't need absolute value. So it's just going to be v to the 5th. Okay,